So let's now look at our general example as we are trying to conclude our session of reflection on a curved surface. So these are going to be our concluding examples. So the question is saying that a concave mirror P of focal length 15 faces the convex mirror Q of focal length 10 placed 25 centimeters from it. And then they are continuing by saying that an object is placed between P and Q at a point 20 centimeters from P. Okay? And then you're supposed to determine the distance from Q of the images formed by reflection first in P and then in Q. And then you should also get the magnification. So, to analyze this very well, it would always be of importance for you to first try out the sketch out of what actually happens. So, if we are to sketch, okay, we are saying a concave mirror P of focal length. I can say if this is my concave mirror, it is therefore P, okay, its focal length here has been given as 15 centimeters, then we call it P, and then the focal length 15 first is the convex mirror Q, okay, of focal length 10. So it is the first thing. In its first year we are having a convex mirror. If it is a convex mirror, its focal length here is 10 centimeters and is placed 25 from it. From this one, this is now Q. From it, we have placed these two at a distance equivalent to place 25 centimeters from it. This convex mirror has been placed at 25 centimeters. And then they are saying that an object is placed between P and Q. An object is placed between these 2 points at a point 20 centimeters from P. Okay? So that means that an object was almost placed here, if I can approximate, and I say this is our object O, and I'm saying the distance measured from P is 20 centimeters. And that means this remaining one is now 25. And then they're telling you that from this idea, determine the distance from Q, distance from here, of the image formed by reflection first in P. It should first go to P and then to Q. How can that actually happen? We shall say that if I have my object here, reflection will first go there. That means that the rays first went here, okay, reflected from there to come here, okay? And then we shall say that in the absence of this ray was supposed to proceed and then form our image I1. That is, in absence of this, in the absence of this convex mirror, the ray will come reflected and form the image here. But because the convex mirror does the work of diverging, instead when it reaches here, it will diverge it now, and then it will appear to be coming from this point here, and that is where our image I2 is going to be formed. I1 is formed, it is supposed to go at I1 in case this mirror was not there. So the action of this concave is to form the image here. But because this mirror is there, it is no longer going to be at this point. It is no longer going to be there. So it will bring its action by diverging it, and then instead it will come at this point and it will be virtual. This one is also going to be virtual because the image is not actually going to be here. It is going to be removed from here and then comes here. But it would be here in absence of that. So that could be basically our diagram that can help us in solving this problem here. So we shall look at the action of mirror P. And if I say action of mirror P, I'm just trying to mean action of the concave mirror. And we are aware that for concave mirror, the object distance we are going to use is the 20 centimeter. And now we have F as 15 centimeters. We are supposed to find what would be the image distance. If this object is acted upon by this mirror here, where is it going to throw the image? And that is the image I1. So we shall say, using our formula here, we shall say 1 out of the focal length, that is 15, is equaling to 1 out of 20 plus 1 out of V. Okay? And then we shall say this 1 out of 15 minus 1 out of 20 equaling to 1 out of V. LCM is 60. Isn't it? Our LCM is going to be 60. 60 divided by that will be 4. Minus 60 divided by 20 is 3. 1 out of V. That is 1 out of 60 equaling to 1 out of. Therefore, V equaling to 60. So that means that this object is going to have its image I1 at 60. And that is only true in absence of that. So that means that the distance from this one up to where this image I1 is supposed to be 60 centimeters. Is that okay? And then we can now look at action of mirror Q, or I'm trying to mean the convex mirror. Okay? Now, what is very true is that this distance here we are looking at is going to act as a, or I can first say, this image here, which is here, is going to act as the virtual object. It is going to act as a virtual object for this lens to form its own real image at I2. The image of this mirror, which is I1, is going to act as object for this second mirror Q to form its image at this point. And this image here is going to be virtual with respect to this one here, because it is the one that made it virtual, therefore it is virtual to this, but real to the other one as at 60, but virtual to this one at a distance of 60 minus 25. So U will be negative 60 from here up to here. Subtract away that to remain with this distance here, minus 25, and that is giving us negative 35. We are saying it is a negative, okay, but with respect to this, because it is actually not there, it has been shifted. Okay, it does not actually appear here, it is removed from here, so therefore it is virtual, but virtual for this mirror here. And we are saying V is what we need, and F is negative 10 centimeter. So we can also still use our formula 1 out of F equaling to 1 out of U plus 1 out of V. And then 1 out of negative 10 is equaling to 1 out of negative 35 plus 1 out of V. Is that fine for us? And then I can say 1 out of negative 10 plus 1 out of 35 is equal to 1 out of V. Where is our LCM? Our LCM is going to be, you can say 70 or negative 70. Okay? I can say something like that. So I'll say this divided by that times that will be negative 7 plus this divided by that, it will be 2. Therefore, this 1 out of V, okay? 1 out of V, I think I can work it out from here. Or I need just work it next here to it. So, I can now say that I have negative 5 out of 70 equal to 1 out of V, and V equal to 70 out of negative. What is the 70 divided by that? That is around negative 14. V equal to negative 14. Please, you can feel free to confirm by yourself. What is 70 divided by 5? Is it true that it's 14? You can confirm. So we are having 70 divided by 5. That is 14 negative. So that means that the image is virtual. So the distance from here up to here is 14 centimeters. The negative is implying that the image is virtual. So you shall say the image is 14 centimeters from Q. That if we measure it from this mirror Q, the image is 14 centimeters from it. And then we can now look at our second part. Our second part of the calculation is saying, what is the magnification? The effective magnification. Magnification can be magnification 1 times magnification. To get the resultant magnification, we get magnification due to this times magnification due to this. Okay? So, my magnification will be V1 out of U1 times V2 out of U2. And that is giving us what is the image distance in the first case. Is the 60. Out of the object distance, the first case, is 20 times the image distance in the second case is the 14. Out of the object distance in the second case is 35. So what is my answer there? You can press and see. This can reduce and you get 3. So what is 3 times 14 divided by 35? That is 1.2. I'm getting 1.2. Okay? It's giving me 1.2. Let me try again and see. That is cancelling 3 times 14. Getting that and then divide by 35. That is 1.2. So, we are saying our magnification is 1.2. And then I can say, therefore, the magnification produced is 1.2. So that is basically our magnification. So let's meet in the next example of our session.